Omid Mogodam. I'm with Virtual Incubation, and Virtual Incubation is a privately held incubator company based in Fayetteville, Arkansas. And CardioWise is one of our portfolio companies. I'm the interim CEO of CardioWise. We have 14 companies in our portfolio, ranging anywhere from nanotechnology to pharmaceuticals and semiconductors. In the good old days, practice of medicine was about answering the question of whether things are normal or not normal. In the really good old days, it was mainly about being dead or not dead. Infectious disease would come and level the town, would kill king and pauper alike. But since we have conquered infectious diseases, the question is more than just normal or not normal. It's how normal or how not normal. And I think we have an answer for that in the cardiovascular area. Cardiovascular, as you may know, is a large problem within our healthcare system and everyone else's healthcare system. 2,400 Americans die every day from cardiovascular disease, #1 killer, actually. Estimates are that 1 in 3 Americans have some form of cardiovascular disease, either diagnosed or undiagnosed. Believe it or not, 2008 is the last year that we have information. The total spent in the U.S., direct spent, was $156.4 billion. And typically, for many people, first indication of any problem in CVD is a heart attack. And there's really no shortage of clinically effective therapeutic interventions for CVD if you can diagnose it early enough. But the key to survival of that first heart attack is really management of this disease. You have to detect it early, and you have to do effective follow-up. And as big of a problem as this is in the U.S., it's even a bigger problem in some other countries overseas. What are the challenges of diagnosing CVD? Again, there are no shortage of tests in this area, either imaging or non-imaging tests. There are at least 10 different cardiac tests that are routinely used. 3 or more imaging techniques are used typically on a CVD patient. Many of them are ionizing, meaning they use X-rays, they use dyes, any sort of contrast dyes or fluorescent or other taggants. There are 3 common areas that are used that the imaging techniques are used for: coronary, valvular, and myocardial function of the heart. And the qualitative nature of these imaging tests introduces a lot of bias and really takes away the effectiveness of this imaging and follow-up cases, meaning that if there are 2 cardiologists or 2 radiologists reading the different imaging tests, they might come up with various solutions or various diagnoses, or how your follow-up care is going. And in reality, there's really no comprehensive single test for CVD. To summarize, there is a lot of inefficiency in the system. A lot of these techniques are invasive. As a result, they're risky and time-consuming, and also clogs up our healthcare system. So what is the CardioWise technology? The idea here is to develop an actual single scan that would map all 3 areas of functionality of the heart with a single MRI scan. At the center of this technology is the idea that you can, when you capture the series of slices of MRI, you can actually measure the movement of various points of the heart as it is in motion in these slices. And actually, if you can keep track of it, you can build a model that would give you the strain elements, the strain points at very fine detail on the heart muscle. And this strain map, going through a finite element analysis, very much like a like a CAD/CAM model that's used for airplane or car design. And that finite element analysis would allow you to actually build a model that gives you very, very fine detail of the workings of the heart muscle. And the final image is a 3D contour map that has heat maps and shows the areas of functionality, which parts of the heart are working well and which parts are not. So blue is good, red is bad, and as simple as that. There's actually one other portion of CardioWise technology that goes beyond building this model, and it's actually a database of normal hearts that have been built over about 20 years of research that has gone into this work. And that very valuable database is what the patient's heart model is compared against. And the delta, the difference between those two, is really what shows which areas of the patient hearts are not working well. What are the market opportunity here and the drivers? The total available diagnostic market in the US is about $900 million. And that's with today's number of MRIs and MRI centers that are in operation in the US. And that's actually growing rapidly at about 9% a year. The total available informatics market for the information that you collect over the lifetime of CardioWise is yet unknown, but informatics is becoming a much more lucrative business in healthcare as more of our work and diagnostics is actually moving to the EMR and EHR and centralized databases for patient care. The factors that would be driving the cardiac MRI growth are, one of them is the large install base of MRIs, as I mentioned, 11,000. They are non-invasive nature of this test, and that is becoming actually a more understood issue in imaging, especially diseases that require multiple imaging tests over many years. Higher accuracy of this test, so the qualitative nature of a study is taken out of the system, and also pressures from payers, CMS, employers, large employers, payers, to limit the multiple imaging tests because of their costs. There are also some other additional drivers of market growth here. The issue of cumulative radiation is becoming visible to lawmakers. So there might be actually rules coming out of CMS and FDA as a result of that. Our aging population means more instances of CVD. And also there's a market trend in acquisition of cardiology practices by large independent delivery networks, integrated delivery networks, hospitals, and which takes some of the imaging functionality out of these smaller cardiology practices and put them under the radiology department in the hospital, and which means that they go back to the issue that they need to be utilizing their machines at capacity. The business architecture of CardioWise is around the software as a service model. The idea is that there would be a data center, and that's where the software is. So your software functionality is a URL. As an imaging center, you would be uploading the raw images into that URL, and what you get in return is the report and the model. So the model delta between that and the healthy hearts, and also the report. So what goes inside around this database? We have a software for proactive health. That's where some of our informatics comes in. Where that comparison of your or the patient's heart with the healthy hearts comes back. So there's an analysis there done. There is this idea of hosted data and analytics. So all the data that we collect from all these from all these studies are captured there and analyzed. It's private and secure. HIT has to be, so it would be HIPAA compliant. And there's also a consumer option to save your data for future comparison, something that doesn't exist in our healthcare system today. As you might have thought, this would be an FDA device, so there is some regulations around it. MRI image processing is regulated by FDA as a Class 2 medical device under CFR 8 something, and it's a picture archive and communication system. Those of you familiar with imaging, that's the so-called PACS systems in hospitals. And what's the strategic objective here is to obtain FDA approval to market CardioWise SaaS tool within 12 months. And there is precedence for that, so it's not a de novo application. It's not a new thing. It's been done before. So it should not be more than 12 months. The regulatory path is seek the pre-market notification, which is the 510K, rather than the more difficult one, which is the pre-market approval, the PMA. But since there's plenty of precedence there, it should not be a problem. Timeline, clinical study of 12 months or so, and FDA review about 6 months, and FDA approval expected 12 to 18 months from funding. And that 6 months there is some development time that we have to put into it. Our sales and marketing strategy, pre-approval and post-approval. In the pre-approval, we just have to build the base, create our presence, distribute general information about the capabilities that we provide, appoint a scientific advisory board, done, and cultivate strategic relationships with equipment makers, the so-called device OEMs like Philips and Siemens, PACS vendors like Carestream, the old Kodak, and Fuji, Agfa, and such, and radiology service outsourcing companies like Intrinsic Imaging, and actually a new company that was recently formed to be the price line of radiology service. They buy excess capacity and then they sell them like eBay does. Attend conferences and trade shows, basically get the word out, and continue our clinical research with the inventors of this technology who are based at Washington University in St. Louis. Post-FDA, deploy a small sales team across the U.S. To implement our 3-tier strategy, going after the large centers of excellence, places like Cleveland Clinic, Texas Heart Center, and such. Tier 2 would be the remaining cardiology practices, the ones who have not been absorbed into hospitals yet. And Tier 3 would be imaging centers and large hospitals. And also focus on group purchasing organizations like the National Coalition on Health, and health plans and employers as the ultimate payers for the service. What are our milestones and the use of funds? In our Series A, we need to raise about 1.5 to 1.8 million to get to first revenue, which is estimated in 18 months. The current state of the technology. CardioWise, we licensed the current software, patent, and database of normal hearts from WashU. And this technology has been in development for about 18 years, and it's been has received NIH funding during all that 18 years. So there's a large body of clinical work that's been done, and also a large body of software work. So actually our software development task is not as draconian as one might think, because good portions of the software was written by professional software companies, and not just academics. So our key technology strategic objectives are to convert the current single machine MRI software that we have today to scalable SaaS software. And we also need to create a web-based customer entry point, that URL, with a backend, start small, for demonstration purposes and as version 1 of product release. And the third objective would be to create a highly scalable backend while we're testing the smaller version, our version 1. And do these development tasks in parallel with the FDA approval process, as I mentioned before in the slide before that. The startup team, I'm the interim CEO. I have 20 years of experience in imaging and medical software and devices, genomics, and I founded a few companies for large entities and small entities. And Steve Spear, who we're in the final stages of conversation with, to take over as the CEO, is an experienced software executive along with CEO experience, with large-scale software development and also startup experience. So Steve will be taken as the CEO shortly. Donna Romer, who I've worked with in the past, has had a lot of both imaging and SaaS experience in development and also as a high-level executive, not just here but overseas in Japan as well. Kimberly Fuller would be our business development person. Dr. Pask, who has the dual role of chief marketing officer, the inventor of the technology, chief medical officer, who's also the inventor of the technology and also heads our scientific advisory board. And since we are part of the VIC family, we can also draw from a large number of very experienced professionals that are part of the VIC core team, like CFO, HR, and other services. Who's on scientific advisory board today? As I mentioned, Dr. Pask heads it as his dual role as the chief medical officer as well. Dr. Brian Cubbs, who's the co-inventor of the technology, medical physicist, also at WashU. Dr. Paul Crawford, who's currently at Intel as a research scientist, also was the CTO of ON Diagnostics, which was a medical imaging software company based in Irvine. Dr. Mark Boguski of Beth Israel and Harvard Medical School. He was the founding director of Allen Brain Institute, large drug company informatics experience at Merck, and former VP of research at Novartis. Additionally, he was one of the founders of the Human Genome Project. Dr. Amit Mehta, he's VP of Intrinsic Imaging, and Intrinsic Imaging is a large imaging core lab based in Texas. Bless you. Any further questions after this? You can always email me. It is in your. And I'm open to questions now.
Questions? Questions out there?
I believe with MRI you can also visualize the well, let me ask, can you see the coronary arteries as well as the valves?
Yes, you can. There's some body of work that's done around measurement of time of flight for blood going through it. There's a limitations on how big the artery, how big of a vessel you can image using MRI. But that number is getting smaller and smaller as the MRI machines are getting bigger, as the size of the magnet's getting bigger and bigger. So the answer is yes, we can, and it's getting much better.
The valves are straightforward, though, aren't they? I mean,
the valves are straightforward.
So when you provide data to a physician, you'll be able to not only give them the strain analysis, and I guess it's the health of the muscle, basically.
Yes.
But you'll also be able to say valves look good.
Yes.
But you don't have the answer to the coronary arteries yet, or is that something you're working on?
It's something we're working on, because it's work that has not been put in the software, but it's something that we will develop for the commercial version.
Okay.
Can you tell us what is included in this report that's generated? You talked about the fact that MRIs are subject to subjectivity of the physicians who are evaluating it, and all I see here is a picture that's in color, and that looks like it's subject to a lot of subjectivity as well. So can you tell us how you are eliminating that subjectivity?
What I meant
and what's included in the report?
Sure. What's the subjective portion of it is that doing the same thing with the naked eye, you basically are going to take two consecutive or two successive slices and try to discern from it changes of 0.5 millimeter or less in the wall of the left ventricular, for example. That's the subjective portion that I was talking about. There is really no subjectivity here. This is a mathematical model that has been built from the actual motion of every point on that slice. So once you radio frequency tag the image and it moves, it's the movement that we're measuring. So there's really no subjectivity that goes into it. And the report that comes back basically talks about what are the different elements in this model, which portions and how much. It's that heat map, and that's the scale that comes back, and that's what the report looks like.
So you mentioned that there are at least 3 different studies depending on progression of the disease for a patient. What have you talked to imaging centers and thought through sort of the unintended consequences of doing one study now, fewer revenue generating studies for those imaging centers? What are sort of their pros and cons from their perspective on this new technology?
That's a very good question, and actually, yes, we have. So, so if you think about it as a curve, at the low end you have the echocardiogram, and at the high end you have angiograms. And so if this is the toe and this is the shoulder of the curve, these two parts I don't think we're going to touch at the beginning. It's everything in the middle there. And there's a desire within the imaging centers to move away from ionizing radiation, and anything that has to do with contrast dies, because they can see the regulatory handwriting on the wall. Plus, they're spending a lot of money on upgrading their MRI machines, not on their CT machines, not on the other things. They're not buying new thallium SPECT machines or anything, or nuclear medicine machines. MRI is sort of up and coming imaging device for them, and they have an interest in keeping the MRI utilized at 100%. So for them, it's actually it's a better revenue generator than the other ones.
So are you anticipating that this would be used mainly in follow-up of disease progression? And do you see a role for this in screening, like a colonoscopy is the recommendation for 50-year-olds?
It would be great if it could be used for screening, but that would be a bridge too far to ask for $1,000 test or $800 test. That's screening. But yes, if it was available as a screening option, it would be a great screening tool, because all the statistics that I mentioned at the beginning, 1 out of 3 having the disease not knowing, and the first indication would be a heart attack. A lot of those people would know earlier that they have progressive heart disease.
This may be a little bit of a multiple level question, but could you talk me through the pricing? What would the upfront cost be? What would the monthly cost be, since it's a SaaS model? Mm-hmm. And then what would the payback period be?
So I have a couple of examples, a couple of companies that are moving from their sort of software licensing to a SaaS model in the same space, not in the post-processing of raw images space. There's no other company in this space. Terra Recons and Vital Images. These are two multiples of $100 million in revenue type software companies that offer computer-aided diagnosis software. And they're typically, this is information that I have gotten from various sources, on a typical installation, their single source software is about $90,000 to $100,000 per year plus a 10% service fee. So it's about $100K. It's about $100K, the licensing fee. When it moves to SaaS, it sort of moves away from capital purchase to an easier way of actually billing it, which it's billed in smaller segments. It's billed in $8,000 to $9,000 per month type of portions, which takes it out of the capital purchase and puts it in a different category within accounting. So it's easier for the radiology department to actually acquire those services, and also that number comes with certain number of slices that can be image slices that can be processed through the software, and anything above that would have a bump up. So that's sort of the pricing that the imaging centers are using today. And there was one more question that you had. It was payback period. Typical payback is about 6 patients. In a typical slice count for something like this could be in the hundreds. And that the flat fee that they charge, the $8,000 to $9,000, that would cover about 6 patients or 6 studies.
Omid, one question. The R&D component of this, does the database allow you to reach back retrospectively into patients that have, been examined before and use that to further develop the technology, or you have to do everything prospectively?
It's certainly something that we can build into it. Question is, we'll be a covered entity under HIPAA, so we probably can capture that information and include it. One of the things that we thought about was this option to save the data on behalf of the patient. So that would be a personal health record type of offering, something maybe through Microsoft Health Vault or Dossier. So you can actually save your study for later comparison. Nothing like that exists today. There was a company a few years ago called MyNDMA that would allow women to save their mammograms, but that they didn't go anywhere.
Real quickly, you've touched on some of these things. I see dollar signs, but nowhere. I don't know how big is big. I mean, what sort of order of magnitude do you see the company multiple years out following launch? And then second part of that question is, you said it takes about $1.5 million to $8 million to go 18 months to the initiation of revenue.
Yes.
Beyond that, what sort of financing do you forecast will be required? Because that's getting to revenue and getting to cash flow break even or positive is, could be quite two different things.
That's true. I skipped some of that information here. If anyone's interested, I can provide the rest of the financing model for you. Typically, I mean, this is the way we have worked it. Is the Series B would be anywhere between $5 to $8 million, depending on how the market has responded and what we need to spend the money on. And hopefully by that time, we're talking about around 20 to 25 million valuation for the company. And in Series C, taking that to $50 to $100 million is probably going to require another 15 to 20 million. And these would be in increments of 18 to 24, building that 6 months for raising the next round.
What would be the annual run rate at that point?
I don't know that off the top of my head. The size of the company would grow from a dozen or so to about 40, and then from 40 to about 100.
Other questions? Excuse me. Okay, thank you very much, Omid. Thank you.